Hey, hello everyone. Welcome back to our Wednesday weekly live streams, part of the GraphQL January series. This is Praveen, developer advocate at Hasura. I'm doing part two of our building full stack real-time apps with React and GraphQL today. Last week, if you've tuned in, I was going over how to create the backend with Hasura GraphQL on cloud, setting up some tables with migrations and metadata, and some permissions along with auth. And we also did some code with the React where we integrated some queries and mutations. In fact, uh, just the UI that you're seeing right now, this is the setup that we've configured so far. And we're done with showing a list of to-dos from the database. And we're also done with creating a new to-do through a mutation and updating some cache using Apollo client. So we've been using Apollo client on the configuration for making HTTP calls to GraphQL, and Apollo client also takes care of caching for you. So that's the current status of the app right now. And today we'll be wrapping up the remaining portions of the app by covering GraphQL subscriptions. We have more mutations to implement, like toggling to-dos, deleting to-dos, and creating a new to-do is already done. But then there's also like a real-time feed where to-do can be um, populated based on button clicks. You can have to-dos coming in from older tasks and to-dos coming in from newer ones, right? So a bunch of things to implement. Um, so I'll start off with where we left last week. I think we wrapped up, obviously we wrapped up queries. In mutations, we went over the insert to do mutation, and we used the cache update by calling in um, cache.read query and write query to update some data. So this is where we are at right now. So in case you have not uh, looked at last week's stream, I'm just going to post a comment for part one so that you can watch that. And I'll also drop in links for the boilerplate app. That's the link for the boilerplate app with Hasura migrations as well. So we apply the migrations and use the boilerplate app to begin the UI. This had the UI components pre-written, and we started with the Apollo client setup. So that's where we are at right now. What we'll do is we'll begin the remaining portions. The first thing is obviously optimistic UI updates that's pending. So why would you use an optimistic UI? So what is the use case of an optimistic UI, right? If you look at our current app and the components over here, so let's say I'm changing some data by toggling a to-do or like deleting a to-do. Let's say I click on this. Obviously, the implementation is not done yet, but ideally what should happen is as soon as I click on this, the HTTP call is made to the database, and some state is getting updated on the front end, and then you get to see that this is a completed to-do. Now, that could be some delay between when you make a click with your mouse and when there is a HTTP call response coming in from the server. And meanwhile, the user is in a state uh, of not knowing what the loading state is. So The way to actually overcome this is to be optimistic about the response. Assume that the response will come in from the server, and it will be like a successful response. In which case, if I want to toggle a to-do, I would want to complete the to-do. And if it's already a completed to-do, I would want to like invert the status, right? So that's the typical state update that we want to do. Uh, with optimistic mutation, the only thing that changes is that you assume that the request that will be made will be successful, and you optimistically change the state on the front end even before the actual HTTP call is completed. And so that the user experience on the front end is pretty seamless. So as soon as I click on this, it should ideally uh, just instantly show me some feedback. I'll show you that example on the live app, which is a completed app. So this is the to-do, which is already like completed. What I can do is I can click on this, and there's an instant feedback of an update that's happened, and the HTTP call could have either gone instantly or it could have happened a little later. But the feedback on the UI is actually pretty instant. So even if I like toggle between 10 different times on this, the state update is instant on the front end, but the HTTP call might be delayed. I mean, not intentionally delayed, but the response takes a little more time than usual, right? So instead of blocking the user for the response to come in, we would just be optimistic about the UI and then respond back with some data. And so what happens if the server returns an error? Um, in that case, we would want to revert the status of the optimistic mutation that we did. So the previous case was we actually assume that this request will be successful. In case of an error, we would just invert back to the original state of the front end, right? So that's the idea behind optimistic mutation. Um, the reason why it's easier to implement with GraphQL is that you know the types pretty well, and the client is given a seamless way to do it as part of the mutation API call. So that's the implementation that we're going to do with this. The first thing is to update the toggle state of the to-do. What I'm going to do is I'm going to copy this mutation and then just trying out on console. So go to GraphQL and toggle to do. So I'll also open this data tab in a new one so that we can have a look at the different to-dos. So obviously on the UI, I can see that there are a bunch of to-dos. Created a to-do is the first one. I would want to update the value of that, the state of that. So the ID of that to-do would be 3. And I'll just pass in a couple of variables here. So ID would be 3, and is completed would be true because the initial state is false. So it's completed, and we would want to invert that to true. This is the variable that we'll be sending in. And if I make this query, so I've passed in the admin secret. I'm not logged in as any particular user, which means that I need to actually pass in the token correctly. So what I'll do is just go to this one and probably refresh this app to see what the auth token looks like. And we have the GraphQL request going in here with the barrier token. I'm just going to copy this. So this is a GraphQL call being made for, I think, fetching the list of to-dos. This is an existing GraphQL query implementation that we did. I'm just taking in the token from there, and we'll add this as another header over here, followed by the barrier token, and we'll remove the admin secret from the headers. Ideally, we would just want to use the token, and if I inspect this, it'll give me my user data and the user ID. So the user ID value would be automatically attached to the to-do user ID column. Right, so we have an affected rows response, and we can rerun this query, go to sort it by ID. So we have a created a to do is completed is true. So now I have updated the is completed boolean basically by inverting the value manually to the console. And if I load this page again, I should be able to see that this is a completed to do. And we can see that this is a completed to do now. So this is the mutation that we want to implement for toggling it. The mutation is very simple. We are just calling update to dos, and we are passing in a couple of arguments. One var clause to say what is the to do ID, and the other argument is to set the values, which is completed, because we want to update the status of the to do, and is completed is the status of the to do, and we're just passing in a boolean. So those are the two variables for which we have defined the types, the int and boolean, and we're returning the affected rows to just get back the response from the server. Right, so this is the mutation that we'll be integrating on the front end. And to start off, we open the to-do item file. So this is inside the to-do folder. We have this to-do item.js. And what we want to do is we want to import GQL as we typically do for defining GraphQL queries. And this would be from Apollo client. Right. And inside the to-do item component, oops, yeah, got it. I think it is opened up this guy. Awesome. I'm going to define the mutation. So this would be toggle to do mutation, followed by GQL, followed by the mutation string. Okay, so we've just imported GQL, and then we've defined the toggle to do mutation, which we just tried out on the console. Just going to remove the white spaces. And the next step is to use the hook, the use mutation hook from Apollo client. So if you remember from the last stream, we did call the mutation, the use mutation for to do input. So this is the usage. We have use mutation being imported from Apollo client, and then I think we're using it over here, followed by the cache update. So similarly, we'll want to do the use mutation call over here. I'm going to call use mutation, and I'll have to define mutation that I can call. This would be toggle to do mutation. And I'll just call the use mutation hook, and I'll pass in the toggle to do mutation that we just declared above. Awesome. So now we'll need a way to call this toggle to do mutation somewhere. That will happen inside the toggle to do function that's already declared for us. So inside this, what we'll need to do is we'll call the toggle to do mutation. And this mutation would have a few arguments that we can pass in. The first one would be variables. And the variables, if you look at our mutation over here, the toggle to do, we have a couple of variables that we need to pass in, which is the ID. And if you look at the usage of this ID variable, it's over the var clause, where you're just passing it for the $ID over here. So this is the to do ID. And we need another variable called is completed, which is a Boolean value. So we'll just send in both these values, ID to start with, and the to-do ID will come in from the to-do object. So we have the to-do prop coming in for this to-do item component. So we'll say to-do.id. And next up, we would want to do is completed. And the way we would do this is invert the value of current is completed value. So we'll do an exclamation mark to do dot is underscore completed. There's slight difference between our usage of is completed being camel casing on JavaScript side and underscored on the database side. You can also like rename or maybe like add alias to your columns on the database side. And the GraphQL API that is generated will have the right casing that is possible. But meanwhile, we'll just keep using this casing. The next um, argument that we can pass in would be optimistic mutation, optimistic response. I would just say optimistic response, and I'll give in a Boolean true. We'll come back to this later. And finally, we have the update function, which would return, which will perform some actions. So first thing is to read something from the cache, read the existing list of to-dos from the cache. Then the next step would be to process data, which we just received, and then write back into the cache. So broadly, these are the three steps that we want to do for this mutation to work. If you look at this definition, we have the toggle to do mutation defined over here. This is the mutation query, the GraphQL mutation, and this is where we are actually triggering the mutation to execute inside the toggle to do function. So if I look at the toggle to do, it's being called on change handler of this input box. So this will be called whenever there is an on change on this checkbox, and we are calling this toggle to do. Inside that, we are calling the toggle to do mutation and passing in some variables and an update function to be called for cache updates, right? So if this mutation is executed, the record will be updated in the backend. But for the front end to get updated, we need to read and write back into the cache, because the state is maintained on the front end, and uh, the response, once it comes back in the server, we'll have to process it on the front end. Cool. So to read from the cache, we'll need to import the existing query, because we need to make a query to the cache to see what's the existing list of to-dos. So what we'll do is we'll import from the private list component the fetch private to-dos. So if you look at the query for fetch private to-dos, so this is the query that we've defined earlier for the to-dos. So we'll need to import this and then use it over there for the cache. So I'm going to go to do item. I'm going to import fetch private to-dos. And this is from the same directory structure. So this would be to do private list And the usage for this would be simple. We'll need to read from cache. So I'll just say existing to-dos, and you will say cache dot read query, followed by the actual query that we imported. That would be fetch private to-dos. Does that have any variables? I don't think so. I think it's just a simple query which is made to fetch the list of to-dos. So this is the list of existing to-dos. And let me look at some queries for mutation. The update to-dos happening. There is okay. So the syntax for this would be that it's not an argument. It's basically an object of arguments, so that we need to pass the query for the read query. This would be query followed by variables if there are any, and followed by other arguments, right? So this is the read query for existing list of to-dos. Meanwhile, Kaushik says, hi Kaushik, glad to see you here. And yeah, do let me know in the comments if you are stuck at any point of this. And the next step is to process data. And the processing of data is all about seeing, fetch the list of to-dos, map it over them, and then just see if the state of the to-do has changed, which is the completed state, and update that value in the cache, right? So the way to do is you have to find the list of new to-dos that we want to write back into the cache. So that's the constant, the new to-dos, and the value for that would be mapped over existing to-dos. In fact, existing to-dos would give us fetch private to-dos response. So that would be dot to-dos in the response, or data dot to-dos. We would say to-dos dot map. We would get, let's say, maybe to-do, which we'll call as t in the argument. And here we would want to see if the to-do ID matches the existing one. So the one that is mapped over needs to be verified with the current to-do that is being rendered, that is being processed. So then we'll return back the to-do, and then we will change its completed state, saying toggling between its complete. Just going to do some little formatting. We return this. If not, we return back the old to-do. The logic over here is that we're checking the to-do ID from the existing to-dos. We're mapping over existing to-dos and then checking if this exists in our current to-do component in the prop. And if so, we're just spreading over the current to-do and then updating the state of is completed value. We are basically just toggling between that value, because that's what has happened on the functionality side. By toggling, you mean just change the status, invert the status of is completed. This is const new to-dos. And finally, what we want to do is we want to do a write query into the cache. And the query would be the same. We would want to do fetch private to-dos. And for data, we need to pass in the latest to-dos, which would mean to-dos followed by new to-dos. This syntax is basically just given the query and then the data, the new data that needs to be returned back to the cache. We're sending in the to-dos key, which is the the response structure, and followed by the values of the new to-dos. This new to-dos would be an array. Since we're mapping over this, we'll get back an array of to-dos, and that's what we are assigning for the cache. All right, so this should be it for the mutation for toggling between to-do state. Meanwhile, I'll just refresh this app. Right now, the HTTP call is being made for everything. So here I have updated the state, so I can just do this. And you can keep seeing the queries being made. In fact, if you keenly notice the speed at which the status gets pending and the speed at which the UI is getting updated, you can see that the UI is optimistically getting updated even before the response comes in. So I'm just going to redo that once more to give you an idea. The UI is getting updated, but the status of some of the responses are pending, and it eventually gets completed. But the UI is updated real time on the front end based on the speed of the clicks that I do, and the status of the response is actually slightly asynchronous, so it can happen on its own pace, and uh, and it will not be a blocker on the front end for the mutation to proceed. Right, so this is the first part of our optimistic mutation, which is to say toggle the state of the to-do. The next one would be to execute a delete. So we've done two types of mutation. We've done the insert, we have done the update for an existing to-do. The last one would be to remove the to-dos. So we'll go to API Explorer and then put this in and then try out the delete mutation. The mutation is basically just saying remove to-do calls delete underscore to-dos query. That is delete underscore to-dos mutation, and it passes in the var clause for the ID, which will come in from the to-do ID variable. And I'm just going to reuse, or maybe I'll just pass in a different ID. I'm just going to check the data. The data that I have under my username, I'm going to make use of, let's say, 5. This works. And the deleted to-dos mutation is successful. So we've got the affected rows 1 getting returned back. Awesome. So now we'll import this in our to-do item.js the same way we did for the to-do input. So we just implemented toggle to-do, and we have this remove to-do function over here, which needs to call in the remove to-do mutation. And I'm going to define that over here. Say remove to-do mutation, followed by GQL, followed by the mutation. And after this, we would want to define the mutation as we did with the hook. This would be remove to-do mutation, followed by the use mutation hook call. And we'll pass in the mutation. It's the remove to-do mutation. So now we need to call this remove to-do mutation inside the remove to-do function. That is being called whenever this button X is being clicked. You have this on-click handler which calls remove to-do, which is just stopping the event propagation from happening. Basically, any page refreshes and so on will not happen. And I would now want to call this remove to do mutation, followed by the arguments for this. We would want to send in the variables for this mutation, which would be ID. And the ID of this would be the todo.id. And we'll also need to do the update mutation for this. So let us go back to the forward. So again, optimistic response being true, and then we're doing an update cache, read query, do some operation, and then do some write query. Cool. So same thing that we did for the previous step. Write an update for handling cache. Again, same thing, read query from cache, process data, write back into cache. So the read query from cache would be similar, existing to-dos, which would be cache dot read query, and I'll pass in the query. This would be fetch private to-dos. This time around, because we're deleting the to-do, the processing of data is basically just to remove the to-do from the list. The existing to-dos would be the same code, and the next step is to write the filter to say don't include the current to-do when you are mapping over. So the new to-dos we might have would be existing to-dos.map. Not map. So we are basically doing a filter, and the filter would have key.id not equal to to-do.id. And I think we are missing brackets. What we're doing is we're doing a filter on the list of to-dos that we read from the cache, and then just removing the record which has the same to-do ID, which is the same as the current one. And then finally, we'll just do cache dot write query. Query would be fetch private to-dos, and data would be to-dos followed by new to-dos. Cool. It's very similar to what we did on the toggle to-do. In fact, the logic for reading and writing into the cache is the same syntax. It's just the custom code for processing what you want to do with the list of to-dos. Either you want to toggle the state of the to-do, or you want to remove it from the list of to-dos, or maybe even you want to add it to the list. That is the processing that will change between both these mutations. Going back to our UI, and I'll probably do another refresh. And toggle obviously already works, so I'm going to test out the delete, and the delete actually happened. So we got the response, the affected rows being 1, and we've got the delete working. We can keep trying out for newer to-dos, and yeah, there's a slight delay due to the response being delayed, and hence you have the UI getting updated slightly delayed. Cool. So this is covering all mutations now. We've covered insert, we've covered update by toggling the to-do. We've now covered the delete, and if you've noticed, all of these operations follow the permission rules that we have declared above. We have this user role, with insert, select, update, and delete permissions. Select is something that we've already seen, and insert also. The condition here is that there's a user ID column, and we're just filtering based on the session variable called Hasura user ID for that user ID column. And if that condition matches, then you allow some columns, not all the columns. You allow some columns to be either inserted or updated, right? And similarly for delete, we do the custom check for the user ID column. And if the user ID matches, then we allow the delete to go through. If not, we restrict that. So this is all configured at the permission layer, and this is all working on the UI. So another way to test this would be to pass in an ID for which I don't have access to. I have my user ID is this odd zero followed by some value, but there are a couple of other to-dos for a different user ID, and the IDs of those to-dos are 1 and 2. So I'm going to try out 1. And the auth token that I'm using over here is for my user ID, which is odd zero followed by some characters. This is a different unique user ID that I have here. And I'm as that token, I'm actually trying out a mutation to delete somebody else's to do. This shouldn't ideally work. And you can see that the affected rows is 0. The request went through, but it didn't delete any of the rows in the database. So the affected rows is 0 because this token cannot delete the value of a to-do which was created by a different user. So that's the permission working normally. And in fact, literally, we didn't write any code for this. We've just done declarative configuration for this to update and delete the mutation. Cool. So we're done with mutations. And the next step would be bulk delete. So I guess if you look at the UI, there is clear completed functionality, which would ideally clear all the to-dos which are completed in a completed state, which is completed Boolean being true. So we might want to test this out as well. We can copy this mutation, and it's very similar to what we did so far. So we'll go over the API Explorer, try out this mutation, and there's no variables here because we're just trying to delete all the to-dos where is completed is true, and if and the is public boolean also being false. So this boolean ensures that I'm only deleting private to-dos and not the public to-dos that I created. That would be a functionality over this component if you want to delete the public to-do that have been created. But the focus right now is on the private to-dos. So once I pass in this mutation, I get the affected rows being 2. So I have a couple of to-dos which are in the state of being toggled, and these would have been deleted by that mutation. So if I refresh this UI, I should not be seeing that data coming in. And yes, so this mutation has deleted a bunch of to-dos. So this is more like a bulk operation where a number of records are being updated or modified or deleted. So ideally, in a typical UI, you might have multi-check, multi-select, and then perform some operation on that multi-select. And you would be sending in a var clause which will have multiple IDs. So that's the primary functionality for this. And we're just using this mutation for that. Right, so again, I'm just going to copy this mutation, and then go over the to-do private list component, where they're importing the query, mutation, and GQL. To import the query first, which is the get my to-dos. And so this is to basically read from cache and then write into cache, right? Cool. So this could be imported from our to-do private list, right? So we have this to-do private list, which has the fetch private to-dos. And we already have the use query over here. I'll do the use mutation, declare our mutation as well. So this would be remove completed to-dos followed by GQL. And once this mutation is declared, we would want to also declare a way to call this mutation, and that would be this is clear completed, which is fine. We would want to declare this this to do clear completed to do mutation. So we would go to this part of the UI. And this remove completed to-dos is the mutation that we want to call. Rename this remove completed to-dos. We'll call the use mutation hook, which would have remove completed to-dos. And the usage of this again would come inside the clear completed function, which is being called over here. Whenever there is a button click of the clear completed, we would be calling this over here. And very similarly, we would just call remove completed to-dos, followed by variables if there are any. And I think for this mutation, we don't have any variables, so this is fine. You can skip this. We have optimistic response being true. And we also have the update cache that we need to return. So again, over here, this will be read query, process, and write into cache. This would be for existing to-dos. This would be cache dot read query. Is repeating the same syntax that we had in the previous steps. And the query would be fetch private to-dos. Names of the queries and the constants might be slightly different from the tutorial. So, but the functionality is the same. So this constant might be a different name in the tutorial, but fundamentally the functionality is the same. And for the processing, we would want to delete the bulk of the to-dos once we get the list of to-dos. So the new to-dos would be existing to-dos dot to-dos, and we would want to filter based on whether this to-do is completed or not. So if the to-dos state is not completed, keep it in. If it's completed, then ignore in the filter. And then we would delete that in the cache, right? So this would be cache.write query. Again, very similar syntax. Query would be fetch private to-dos, and data would be to-dos followed by the new to-dos. Pretty similar syntax. Just checking in. Yeah, semicolon over here. So this is clear completed. We are calling the remove completed to-dos mutation and then sending an optimistic response followed by the update cache, which will requery, put in, process the new to-dos by filtering out the completed ones and then writing it back into the cache. Cool. We'll try out by refreshing. So I'm just going to open console. Just a second. Yeah, so we have the network tab open. Let me add more to-dos. And we have more to-do too. Right. Now I'm going to just complete these. We have a couple of requests going in. And I'm going to click on clear completed, which would make a GraphQL call. And then it has affected the couple of rows that we wanted to delete. Awesome. So the mutation is working as expected. And I'm just going to refresh this and then move on to the next section, which is subscriptions. Do let me know in the comments if you have any questions so far about optimistic updates and performing all sorts of mutations, both insert and update, and finally both single delete and multi-delete. Cool. So for subscriptions on this app, we have a couple of use cases. The first use case is to display the list of online users based on whether they are logged in or not. The second use case is to listen to this public feed where the list of to-dos are being created. And if there's a new to-do that is being publicly created by anybody, it should appear as a Twitter kind of a style feed, like which will put up a notification at the top of your UI and say that a new task has arrived. And on clicking of this UI element, you would make a query to the database and then fetch the new to-dos. So till that button click, you would not actually fetch that data. You'd only subscribe to the list of to-dos that are newly created. So you would only just fetch the to-do ID and then find the length of the to-dos that you want to show in this brackets. And on clicking of this element, you would make a query and then fetch in some data and then populate the state by updating the cache. Very similar concepts. Load older task is also going to be a query which will be made to fetch to-dos which are greater than the ID that is over here. You can use a combination of a var clause, which is both greater than the ID of the to-do and the timestamp of the to-do. So in this example, I think the ID of the to-do is following a simple auto-incrementing integer. Typically, if you're using UUID, then you won't be able to make a var clause to say greater than this UUID. In that case, the timestamp would be the best approach, where you would say var created at is greater than the last to-dos created at, and you will be able to fetch the newer and older to-dos accordingly. Cool. So the first step in subscriptions is that to make yourself online, like I've already logged in into this app. But for me to appear online, I need to update a value in the database as soon as I've logged in. And that value would be in the users table. For each user, we would want to update the last underscore seen value. And this can be updated only if I have an update from the front end, which makes a GraphQL mutation to update the state of the user on a given time interval. And the time interval for that, according to our Postgres view that we've created, is as a 30-second interval. So on the front end, we would want to create a time interval, a set interval function, which would execute every 30 seconds. And that function is just going to be a GraphQL mutation, which would update the last seen value of the currently logged in user on the UI. And doing so, we would be able to capture that information, and this view would ideally show that user as online. And that's what we want to implement over here. So we would want to import use mutation GraphQL, same things from the online users wrapper. Let's go to online users wrapper over here. And so we have a couple of things to worry about. We want to use the state to say that whether the user is online. So they're like an indicator. And then we need to use the use effect to call the set interval function inside that, which will run on every time the component loads into the component mounts into the UI. So we'll import a few things. So we'll import use effect and use state from React. So the first step is import use effect and use state from React. And obviously the next step would be to import mutation and GQL. But the mutation for this would be this, which is update last seen. Just gonna copy this and do a quick trial in GraphQL. Verify this, and I've done last seen. You have to pass in the variables, which is now I need a value for this timestamp. Let's say that maybe I can pass in now expression, and that works. I'm going to refresh, and the last seen value has been updated over here. So this should ideally mean that my mutation works. Awesome. So this is the mutation that we want to declare, and to declare this, we'll import EQL and use mutation, both from follow clients. And we will also declare this. Let's call this mutation update last seen. Followed by GQL, followed by the query. Oops, I've copied the timestamp after that, so go back to the API Explorer. This is the mutation definition. We would want to obviously define this somewhere. And the next step would be to declare the state to have an indication of the online user. So this would be like an online indicator state, set online indicator. an initial state of 0. And we also declare an online users list, which is similar to this constant, but we'll remove that because we want to keep pushing it and then changing the values of that. And finally, we'll have a use effect where we would declare, where you would call the set interval to update the last seen value every 30 seconds. So this would be execute set interval every 30 seconds. This number is purely based on what we created in the Postgres view. So this is totally changeable on the backend as well. But as you keep changing that in the backend, we have to update the value of the interval over here, or maybe use a generic uh, interval which is far less than what the database considers as online. Um, and then we would want to call an update last seen function. This should be, this is something that we've not declared yet. Oops. Say update last seen. Okay, so this is triggering my macro. And then finally, we'll have state update, which will have set online indicator that we declared above. And this would call in set interval function. And inside set interval function, we would call date last seen, which will be represented in milliseconds. And we are passing in 30,000 to represent 30 seconds. This update last seen would be called every 30 seconds. And finally, we'll want to clean up if there is a component mounting. There'll be clear interval of online indicator. So we're calling update last seen that we'll define, and then we are calling the set online indicator state update, which would be a set interval, which would keep getting updated every 30 seconds. We have the list of online users. We're doing a cleanup uh, to close the set interval with a clean interval. In fact, this is clear interval, the typo there. And that's the use effect logic. Now, finally, we would want to, once we have the use effect, we would want to make use of the mutation itself. That would be update last seen mutation. That would be use mutation followed with a constant that we declared over here. The update last seen mutation. Awesome. So now we'll declare this function called update last seen. And this would do the actual mutation itself, which we just defined above. So this would be update last seen mutation followed by the variables. And this mutation requires the now variable, which is the timestamp. So I would say new date ISO string, give the timestamp value in which is supported by Postgres. So that's the variable that we want to pass. Variables are done, and we don't need to update any cache over here. So typically we would have like an update cache method, but we don't want to do that here because we're not changing anything on the UI. We're just notifying the backend, in fact, updating the backend to say that this user is online on an interval. And that's all. So we don't need any more changes for this. And what we're going to do is we're going to remove some code which is for the online users, and just checking in what needs to be checked. So looking at the logs, let me change this. We have a couple of these values coming in. Awesome. So we will remove the usage of this and remove the usage of online users. And instead of this dummy user list, we would want the list of online users to be updated. That we'll come back to later. Now I'm going to refresh my app. It should be here. Got it. There is a push error online users list, which we've declared above. Let me look at what the other changes required. We have done the mutation. We've defined it, we've called it inside the update last theme. And there is no removal of code over here. So that is still fine. WebSockets are obviously happening in the next step. And for online users, wrapper, we have this being removed. Cool. So we'll come back to this online users later. The subscription needs to be set up with Apollo client, and that will be the new module that needs to be installed. But for this, the update can happen when the subscription gets updated. So I'm going to do an installation of the new module. Back to subscriptions, npm install. While I'll just open up the app.js. This is where we've declared the HTTP link. And what we want to do here is update to WebSocket link and then change this HTTPS to WSS. So instead of this HTTP link, we would want to do, or we want to import WebSocket link. That will be from WebSocket link. We would want to update it, load it from apollo/client/link/ws, I suppose. Yes. And the next step would be to update the usage over here. So instead of calling the HTTP link, we would call WebSocket link. What we're doing here is we are replacing the HTTP link, and all the queries, mutations, and subscriptions will only go through WebSocket from now on. This is interesting because Hasura supports queries and mutations through WebSockets as well. And hence, instead of splitting between a HTTP link and a WebSocket link for queries and mutations and subscriptions, we're using the same WebSocket link for all sorts of queries and subscriptions through Hasura. So that's what we're updating the configuration over here. We are replacing HTTP link with WebSocket link. And the change here is that instead of HTTPS, we would pass in WSS, which is the WebSocket protocol. And WebSockets do not accept headers directly as HTTP endpoint would do. So there is something called a connection parameter. So we would want to send that under options. Take this headers, we'll put it over here. We have reconnect on failure to be true. Then we have something called connection params under which these headers will come in. Yeah. We can also use the connection params as a function, but here I'm just passing it in as an object. Cool. So let me just hide the doc. Great. I'm going to do an npm start now. We have to fix the online users wrapper. So here, the online users list, we'll come back to this code. The online users data as well. This is dummy data. And in fact, we would just comment this out. Online users is not defined, which is over here. Right. So to do this, we need to define the subscription required for this. Let's go back to our subscriptions. The setup is done. And we'll go into the online users wrapper subscription. So this is the subscription query. We'll test this out on the console quickly. Variables over here. There's no variable. There's just a list of online users being fetched from the DB. Currently, there aren't any, so I'm going to change the value of last seen. As soon as I save here, I can see that the subscription is still running, and then I can see my data popping up on the response. And this will go away after the time interval of 30 seconds. So we'll back to that later. Now we'll have to define this use subscription inside our online users wrapper. So I'm going to import use subscription over here. And then we'll define all of these usage of use subscription inside the online users wrapper. So after this would be usage of use subscription followed by the GQL query. So I'll declare the online user subscription followed by the GQL. Now we would want to use the use subscription hook to get the data in real time. Remember our old query, we did the loading error and data for the use query hook. So this would be very similar. This would be use subscription. And the subscription would be online users. And if there is loading state, we're going to return some loading text, ideally a spinner. If there is an error state, return an error. And finally, if there is data, this is where we would want to uh, return the online users data. So we'll go back to the hook. If there is data, we are going to make use of the online users list component. So we'll declare online users list, and the data will be having the format of online underscore users. So we can map over this data. So this would be data dot online underscore users dot map of user. Now here we would want to call the online user component, passing in some key, which would be the user ID. And I think index is not required, but then we'll pass in the user detail. This would be u.user, and that's it. So this would be data. Remove the usage over here. This would be online users wrapper, and we would want to declare a fragment to embed these two. This will be format this better. Will be online users dot length. This will be online users list dot length that we just declared above. Users list. This was a variable that we declared above, and this is online users list again. Fragment is ending, so we have to import fragment as well. Fragments, I could have made use of the shorthand notation, but it's okay. Cool. So instead saw an expression, go line 52. Yeah, we need to send it on a return. This is fine. Let's go to the UI, and we can see that the online user data is appearing correctly. So let's go to the console. There is some sort of a loop happening, I guess. What's happening? Set state inside use effect, but the use effect doesn't have a dependency array. Right, so I'll close this to avoid the rate limiting to be hit. If you look at our use effect, we've declared it over here. We don't have a dependency array, so this is being called continuously. So I'll just put in an empty dependency array. Go back to 3000. And now there will be limited number of queries. There's an error though. So we look at, yeah, so we've hit the rate limit initially. So this is like a Hasura cloud limit of 60 requests per second due to the error on the UI. So I'm going to quickly do an update to my project. Going to upgrade to standard tire, and I'll wait for a minute or so for this to reflect. And meanwhile, we can continue looking at the logic. So we've defined a subscription, which is the online user subscription, fetching this from the Postgres view ordered by the username. And the Postgres view also has a relationship to the user table. So we're getting in the user name in a relationship nested. And this is the use subscription hook where we are fetching in loading, error, and data states. So this is very similar to how we handled the hook for the query, which is to say if there's a loading state, return loading, error, return error. If there is data, then map over the list of users that you get in from the database, and then return online user component. So this is the online user component, which is just having a user prop and then templating the user's name with an icon. So that's all this component does. So we need to map over the list of users and call this component for every user. And that's what we're doing over here, mapping over the list of users and then passing in online user for every user. Cool. So the status of the console looks pretty cool. I think the limit should be removed. Now I'm going to open the app again, refreshing it, and we have the data coming in back. The limits have been removed. And the change this time around would be that there won't be any more HTTP requests for the GraphQL API. There's only one HTTP call for the Auth0 app. But any other GraphQL request for data fetching or manipulation would happen through WebSocket. And this is the initial request for the connection. We're sending in the authorization header. And once this is connected, there are queries, mutations, everything going through this same WebSocket connection, including the response coming back on this and the subscriptions as well. So this is a single connection now handling all of the queries and mutations and subscriptions on this app. And any other debugging of logs need to happen over here. We can see that there are a couple of queries which are being executed multiple times. The one is to update the last seen value of the mutation of the user with the timestamp to just indicate that the user is online. And the next one would be the subscription response, which gets updated every 30 seconds or whenever there is a user who's either gone offline or a new user who has come in online. So that's the different sets of queries that are going through. The last seen mutation is going through every 30 seconds. Cool. So the subscriptions have been set up now, so that's working for us. We'll go to the real-time feed, which is the last section of the app. We still have a few more minutes to cover this. So for this, I'll look at the conceptual stuff first. So on this UI, we have the list of to-dos to be populated, obviously. But then there's a subscription that needs to be run to determine if new tasks have arrived from the database, which is like a public list of tasks. And for that, we need to run a subscription inside this as a public feed. We can technically use the use subscription hook over there as well. But I wanted to showcase like a different use case of use Apollo client and then calling client.subscribe and then awaiting for the response over that. So that's what we're going to look at right now on the to-do public list. So let's go to-do public list over here. So we have some dummy to-dos over here, and we have a couple of empty functions to implement, which is the load new and load older, and the to-dos data is coming in from the state, which we will update once we have legitimate data from the database. And we have some messages for new task being arrived and the count of the to-do. Right, so first thing, we would import GQL for declaring any kind of GraphQL query. So this would be follow/client. And let's look at the next thing, which is the subscription that needs to be listened to. So let's go to the console. Verify this. And currently, obviously, there's no public to do which is common. But the idea here is that the var clause says is public equals true. There's a limit 1. There's an order by for create dissenting. So what we're doing here is fetching the list of to-dos, just one to-do, in fact, and the filter is to say it has to be a public to-do and it has to be ordered by the timestamp that it was created. That's the subscription that we are going to use. So we're going to declare this, type this, notify new to-dos subscription. QL followed by the query string. This is the constant for the subscription. Typically, we could have used the loading error data for this, but then I want to showcase a different way to do this. This would be use subscription in a different component. So I'll import use subscription again over here. So this would be use subscription. And we want to declare a new component before we return this. So in fact, instead of exporting this, we will export a different component as we did for the queries. So we have this to-do public list subscription that's been written newly. We'll declare it outside, and then we will change the default export for this. Right, so const to-do public list subscription. And here we would want to make use of subscriptions over here. So we'll actually move this outside. Constant is globally available inside this component. We have a little bit of state. We have empty methods, and we have fragment over here. Fine. So we'll want to access the loading error and the data states. This would be use subscription and notify new to subscription. Again, similar, very similar loading, return a loading state. I wish I had a spinner icon macro that I can autofill over here. The amount of times I have wanted to return a spinner. There's error, there's loading, and finally there's data. If there is data, then return the to-do list, to-do public list component, which will require some props. So we look at what props are required. This requires the latest to-do prop, and is sending in the latest to-do alone by checking in some conditions. So this would be latest to-do. data dot, if you look at the subscription, this is to-dos. So this would be data dot to-dos. There is any length over there, which is greater than 0, then try to access the first to-do. If not, return a null and then close out the component. And finally, instead of exporting to do public list, we will do to do public list subscription for this. We're instead of returning uh, the 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 component which is to do public list, which has the inner list of to-dos, we are returning the subscription component which wraps over this by calling in the use subscription hook and then sending in the data. Once we have the data, we are just calling the to-do public list with the latest to-do. Cool. So let's refresh the app, which is over here. And I mean, there's no change in the UI, but we can see that that would be WebSocket established for this, and then followed by the subscription that we are running, which is for the notify new public to-dos. So whenever there's a new to-do, we'll get a response. Whenever there's a new public to-do, we'll get a response for this. And then based on that data, we'll update the length of this, which is the new tasks have arrived list. Cool. So now the next step is to think the to-dos. That's the last step actually of this app. So we have a couple of things to do. We have to uh, remove the dummy data from the list of to-dos to be shown. So this is all dummy list of to-dos coming from different users. We have to update it with the right username. And then finally, we have to implement functionality for load older task and load newer task whenever there is a newer task, right? So going back to this code, we're using use Apollo client now. So we have some state to be declared and some use effect as well. So I'm going to make use of this import, use state, and use effects. And the use state would be declared inside to do public list. The state will be declared inside that, and the older dummy data will be removed. And we'll also make use of use Apollo client inside component. So we'll also import use Apollo client. This is where we'll make use of, instead of making a hook call, we'll make use of the client dot query call, client dot mutate call. And that's just like a different way of using Apollo client, where you can call, you can make a HTTP call inside an action, inside like a handler, like on click or a button click. So that's the different use case. It's not necessarily the best way to do this, but just to showcase that you can use this kind of client dot query, we are making use of this use Apollo client. Uh, so ideally, we would use a hook, but this is just an example to showcase different ways to use Apollo client in your component. We are going to declare a state. So instead of this being a static state, we would make this a state and followed by set state. And this would be use state. And we'll have to update the values of these. And we'll remove the values of dummy to-dos, and I'll close in the use state over here and the to-do public list. All right, so there's to-do list, and there's the older to-do message, there's finally a return, and everything is fine in the formatting. Right, so now we need to update values for these older to-dos available and the new to-dos count being available. Meanwhile, I'll go back to check what are the different props being received. If you look at our previous component, which is the to-do public list subscription, we are receiving a latest to-do prop from the to-do public list call, which is sending the exact to-do which is available. So if the latest to-do object is available for access, then we can make use of that for showing the older to-dos being available. If not, we can see that it's false. Right. So, so the condition for that would be to check if props.latest to do exists, and then just do a ternary check for returning a true or false. If props.latest to do exists, return a true, else return a false. And for new to do's count, we would have an initial default state of 0. Previously, the dummy state was 1 to just showcase this UI to have 1. So now with 0, this would have no more public tasks, which is understandable. And the to-do list is also currently empty, which is because we've removed the we've made this array to be empty, and then we've not templated it with the right value. And we also have like an error state, which by default will be false, and then we'll either update it to true or false depending on the status. Now we have two different things to implement, the load new and load older. But we also need to now calculate a few things. We need to calculate the number of new to-dos that are available and the oldest to-do ID followed by the newest to-do ID for using it in different cases. So if you have the oldest to-do ID, then we can make a var clause which is greater than that, and then fetch to-dos which were beyond that. And if you have the newest to-do ID, which will be usually at the top of the list, you can fetch the newer ones after that to-do ID. So there are like two conditions, one to fetch newer ones and one to fetch lower ones. And that's what we're going to calculate. We have to calculate the existing list of older to-do, the oldest to-do, and the newest to-do from the list of to-dos. So to begin with, we're declaring the number of to-dos, which would come from state.todos. Length. Right now it's empty because we've not updated the state, but that's fine. Then we have the oldest to-do ID. So here we have a few conditions to check. So if the number of to-dos are empty, we would select it from state.todos num to-dos -1 .id. If the number of to-dos, this will be if number of to-dos are greater than 0, which is basically a Boolean state. In this case, what we're doing is we're just parsing the to-do value and then getting the last but one value of that to-do to find the oldest to-do. So we have a list of, let's say we have a list of 10 to-dos, and it's already sorted by timestamp, and the oldest to-do is something that will be just -1 in the array length, -1, right? So the index is just we're just minusing 1 from the index value, and if there is no to-do length, then we need to see if there is a props.latest to do, which would also come in from the previous component. And this will be like a nested ternary operator. So if there is a latest to do, then we would do props.latest to do .id +1. If not, we'll just do 0. This is the oldest to do ID. This is just to given a default value. And the newest to do ID would follow a similar configuration. So we'll do num to-dos, if state.todos of 0.id. So in this case, the array index is 0 because we want to fetch the latest to-do ID from the list. And if this doesn't exist, then let's check if props.latest to-do exists. And if this exists, then just do latest to-do.id, and there is no plus or minus to be done, and just taking the latest to-do ID as it is. If not, assign it 0, and then carry on, and then assume that there are no more to-dos to be shown, right? So this is those custom logic that we had to write for determining the number of to-dos and for finding out the oldest to-do and the newest to-do. So this information is useful for the variable part of the query that we're going to make next. So to make the next set of queries, as I mentioned before, we'll make use of the client directly. So we'll declare the client, which will be use Apollo client, which is fine. And let's populate some initial state by calling in a use effect. So we would have a use effect, which would call a load older method. So initially, if you look at our app, the current list of to-dos which are public are not being shown, or the request has not been made yet. I'll also make a few to-dos public before we make this change. I will make GraphQL January as public so that it appears on the UI. And let me refresh this. Yeah, so we'll need to now template that list of to-dos. So we'll make use of the use effect call, which would call the load older. So this would be use effect call load older method. And dependency would be an empty array. This is use effect. So this would call load older. Right now, we've not defined what the load older method needs to be. This is where we'll make a client call to fetch the list of to-dos which are older. And to do that, we would make a query to get the list of old to-dos. We'll copy this to-dos. We'll go to the console, and there is, yeah. So we need to pass the oldest to-do ID to get the list of to-dos. So the condition here is that public, obviously the Boolean has to be true, and ID of the to-do has to be less than equal to the oldest to-do ID. So once we follow this condition, this would give us the list of older to-dos, which we can template it on the front end, created by ordered by created at descending. So this is something that we will implement inside load older. So I'm going to declare this this query using the GQL string. Then we'll make use of error and data for making a client.query. So typically, we would have done a use query hook, which would have made a call to the GraphQL API. But since a hook cannot be called inside uh, a random handler, we'll make use of client.query over here. So we'll declare uh, the variable first. We have get old public to dos. Then the next one would be to get new public to dos when I click the other function. Right. So we'll do get old public to dos. We'll define the GQL query string, and we'll now make a call to Apollo client using client.query instead of the usual hook method. We'll do error data, which would do client.query, and same objects. The query would be get old public to dos, and we have variable, which is the oldest to do ID, which is again the oldest to do ID. So we can probably even use a shorthand notation. Got it. So now this client.query is an asynchronous function. So we'll need to use an await to wait for the response or write a callback. So I would just write an await instead of a callback here. So this is going to give us the data for the older to-dos. Typically, we could access the loading and error state and handle it. We're just directly going to use data.todos. If there are any new any to-dos in the response, then handle that by setting some state. So we have the state we've declared over here for the use state. We are making use of set state to update the values of these. Ideally, we would want to update the to-dos first. So we're going to go to this section, set state. This will have the previous state available. And here we would want to return at the previous state, update a few things, which would be update the to-dos, add previous state dot to-dos. We're spreading the previous state dot to-dos, and then adding it with the list of to-dos we have over here, and we're closing in the bracket. Here, if there are any to-dos, we are updating it to the list of existing to-dos. The previous state dot to-dos, initially, if you look at this would be an empty array. We're just appending to this list. But on further data updates, this would probably already have some data. Then we would just spread this in an array, and then we just appending data and combining them. So that's the set state to update the value, then change the UI. And the oldest to-do ID would change after this update happened. So the oldest to-do ID would be data.todos of to-do.length -1. ID. So here what we're doing is we have a new list of to-dos. And if there's a new list of to-dos, we want to update the oldest to-do ID value to be a different one, because previously our calculation was based on this initial state of to-dos, but now the state of to-dos have changed from the response from this query. So we need to change this data.todos uh, and then find the index to the length minus one index, and then assign that ID to the oldest to-do ID. Right. So if to-dos.length is there, this is the logic. If it's not there, then we'll need to update the state with a different value. We'll again have previous state access. We'll return the previous state followed by older to-dos available being false. So this would indicate the UI that there are no more to-dos and hence don't show the load older button. That's what this would have done. And obviously, if there is a loading state, error state, feel free to handle them. So typically, it will be loading error, a command data, so you can handle them over there. The newest to-do ID, we'll come back to the usage of the newest to-do ID. I'm going to refresh this page. So there's a public to-do that we just added, which is for the ID 1, for the to-do ID 1, I guess. This is the public one. This is the public Boolean value true, which has the GraphQL January to-do. So now that's coming up. So this is being populated because of the load older query being called. Now there's a subscription running as well. So what we'll do is we'll update another to do. We'll just make this a public to do. And then we'll probably see a subscription response coming in here. Yeah, so we're seeing that there is an ID 2, which is coming in as a newly updated to do. Now we'll need to show that on the UI as a notification banner. So we'll come back to that once we do the use effect for the load older. For load newer to-dos, we have another query that we need to implement. Going back to the console and prettifying this. So here, the only change is that the var clause will accept a greater than var clause for the ID, and it will pass in the latest visible ID, so that whichever is there at the top of the list, that ID will be fetched, and a query will be made to fetch to-dos which came after that. So that's this particular query. We'll now add this to our load new method, which is over here. We'll again make this an async method. This would be get new public to-dos. Followed by GQL. And then once the query has been defined, very similar to what we did in load older, we'll actually fetch data using client.query. We pass in the query, which would be get new public to-dos. And for variables, we need to pass in the latest visible ID. Value of this would be coming in from our to-do state. The latest visible ID is the first to-do that is there in the state. So if state.todos.length exists, then the first ID would be state.todos of 0.id. If not, it's return null, which means there are no more, there are no visible to-dos at the top, which is probably an empty state of public to-dos, right? Awesome. So now once this response comes in, if obviously if data is there, then perform state updates. We have access to the previous state. Now we would want to return. This would be spreading out the previous state, and we'll need to update the list of to-dos with the data.todos and adding the previous state dot to-dos. Here, we're just putting in the newer to-dos at the beginning, and hence that is being spread first. And then the next list of to-dos is the existing set of to-dos, which we need to spread and then combine it into an array before rendering on the UI. We're just merging data, but then the order of the merging matters. The new to-dos need to be at the top and the old to-dos need to be at the bottom. That's the state update, and new to-dos count will be back to 0 because we've just now made a change. The new to-dos count is the state which is being used to check that notification. And so that is the new to-dos count. So once this state is returned, before we need to also find the newest to-do ID, which would be data.todos of 0.id. That's the change. Over here, we have the newest to-do ID coming in from the data that we just fetched right now. The newest to-do ID is still not being used. So this needs to be used over here. Let me check. To-do ID, we're updating it over here. And there's a use effect that we need to declare to say that if whenever there is an update, do not bother reloading the entire state. So we need to use we need to add this use effect below this. This will be the use effect over here. So here we're saying that if there is a latest to do, and if there's a latest to do, the ID of the latest to do is greater than the newest to do ID, then update the state and then update the newest to do ID as well. So this is just like a componented update scenario where we don't want like a loop to happen. Return the list of to-dos if there are no more changes. There's a question from Sean. Are you using SWR? Unfortunately, not for this example. This one uses the Apollo client. We're following the Learn course. The SWR one, there's an example over here that I've written over. This is repo. I'll just put it on comments. So sample repo where you can try out queries, mutations, and subscriptions. Cool. So that's the final part of the app. So let's refresh this once more and then um, add some more to-dos as public. Let's clone some to-dos and then make them public. Make request authenticated. Just gonna add 1, 2, 3. We have 7 to-dos that are visible at any point of time in the public feed, and any more would be in the load older list. Just gonna refresh this. And I think the initial list of this would be public true and is completed false, which is fine. User ID doesn't matter. All right. I think the clone, I think I was just probably editing instead of cloning. So I'll have to redo this. I'll make this true. Public 1. So I'm just going to copy this auth0 ID and then just create off 2. And and probably this should be enough, I suppose. Yeah, we have a few public to-dos now. We can see that there are new tasks have arrived, which is 7 because we've added 7 new to-dos onto the database. So on clicking this, there's a query being made, which is this, which is get new public to-dos, with the latest visible ID variable being 2. And this is basically making a query to fetch the newer list of to-dos based on the ID. So that's just populated the list of new to-dos. And if there are older to-dos, that should also work. But right now, this is the last to-do ID, so there are no more public tasks that we can fetch for this. Looking at the comments, Sean has another comment, will have a blog post. This is in fact like a learn course that we have. So I'm just going to share that link again. This entire app is a learn course. I post this link on chat. Yeah, cool. In case you're wondering about SWR blog post, there is one that we've written with instructions on how to use SWR with GraphQL and deploy a Hasura instance and then try it out. So that is so available over here. I'm just going to post that chat as well. And there you go. Awesome. So we've actually come to the end of the stream. We've implemented the real-time feed as well. We've implemented both load older and load newer functionalities, and that's probably the end of this application. We initially missed out the use effect required to handle the did update, the component did update state. Now this is handled as well, and we can see that the UI is now updating newer tasks that are coming in through subscriptions. The online user is already working, and we have the toggle to-dos, delete to-dos, everything working as expected. And that's the end of our real-time app. So we've used a couple of real-time functionalities. One is the online users, which is just a direct generic subscription to fetch from a view. But this real-time feed is like a Twitter-style notification feed where we are making a query after clicking, but the initial list is fetched from a subscription, and the subscription is just like a notification for the user. And if the user makes any interaction, then we make another call to the database. If not, there's no more data fetching happening. There's only subscription to just fetch the ID of the to-do. And yeah, so that's the end of today's stream. That's the end of the full stack app for React. Um, I'll catch up with you folks next week with a Next.js example, setting up a GraphQL client on Next.js and then using Hasura queries, mutations, and hopefully subscriptions as well. Until then, it's bye from Praveen. Thank you for joining in. Thanks, Sean. Thanks for the comments. Thanks for the questions. Yes, Next.js for next week, and hopefully Gatsby as well the following week. So next Wednesdays, so we do streams every Wednesday uh, for this full stack series as part of our GraphQL January campaign. So do follow us on Twitter for the latest stream updates. Subscribe on YouTube and Twitch. We stream over both channels. And next Wednesday would be the Next.js stream, and do subscribe for that. Cool. Thanks, Sean. Thanks for joining in, and I'll see you in the next week. Bye bye.